Katherine Hall-Hertel. I'm an associate dean in the graduate school, and I'm pleased to welcome you. And I know the participants are glad to have your support. So thank you for being here. Let me start by telling you a little bit about the history of 3MT. It started at the University of Queensland in Australia in 2008. They had 160 student researchers present, and it was so successful that it was quickly adopted in other universities throughout Australia and New Zealand. Now it's become so popular that there are over 350 universities holding these competitions in 18 different countries. So it really is quite the phenomenon. Now, what makes 3MT unique is the idea that students have to present their research in 3 minutes with one slide to a non-specialist audience, which can be really challenging, as you'll see. This year's competition is a little different. We would normally be meeting and watching people do this live, but the finalists had the option of re-recording a different video or using the one they submitted initially. Okay, with that, I'd like to introduce Dr. Jill Huerta, who's the Executive Director of the Center for Graduate Life. And Jill will get us started with the program. Thanks.
Thank you, Katherine, and welcome everyone. And thanks to the competitors and also to all your support people for coming today. As Dr. Hall-Hertel mentioned, this competition is a little different from the last several. This is our 4th one, but our first virtual one. And this is one of the times that I really miss seeing your faces in person. But I am grateful that we're able to move forward and to do this in a modified form. And I'd like to take a minute and thank Autoreal Oshana, our graduate assistant at the Center for Graduate Life, who went to a lot of trouble to figure out all the little details of making it work virtually. We appreciate your hard work. I want to start by introducing today's judges and thanking the 3 of you as well. Today's judges come from offices around campus who are very, very strong collaborators with the Center for Graduate Life. So I not only appreciate your help today, but I appreciate your partnership that you offer to us all the time. Wonderful to work with all 3 of these offices. So we have Patrick Madsen, Executive Director of the University Career Center. We have Laura Smales, Assistant Director of Ventureprise. And we have Dylan Klostner, an advisor with the International Student and Scholar Office. Patrick, Laura, Dylan, thanks so much for your time today. A word about the rules of 3MT, which also play out a little bit differently this year. The rules of 3MT state that participants may use one single static slide with no animation, no props, no costumes, no additional media, just one static slide. Presentations are limited to 3 minutes maximum, and in fact, usually those who go over that maximum are automatically disqualified. I can let the judges know right now, we've checked them all and they all fall within the 3-minute time requirement, so you don't need to worry about that. Our judges will score participants. I'll describe how in a moment, and the judges' decisions will be final. In terms of scoring, all competitors will be scored in 2 areas. First, comprehension and content. So did the presentation follow a clear and logical sequence? Was the topic, key results, and research significance and the outcomes, was all of that communicated in language that would be appropriate for a non-specialist audience? In terms of engagement and communication, the second scoring category, that involves whether the presenter captured and maintained the audience's attention, and whether the slide that they used enhanced and added to their presentation and made it more compelling. We are competing for cash today. There is prize money associated with this. The first place winner will receive a $500 award. and be advanced to the CSGS regional 3-minute thesis competition, which will also be virtual this year. Usually you get to travel to that conference to present in person. Second place will receive $300 in award money, and third place will receive a $200 award. We will also vote on a People's Choice Award. So keep this in mind as you're watching the presentations. Think about which ones you like best and which ones you'd like to vote for. And there's no cash award associated with the People's Choice Award, but there's an awesome certificate and bragging rights, of course. I'll introduce each participant, and then AutoReel will share his screen and play their video, and then he'll take it down when they're finished. Then I'll give the judges a little time to score them. You can give me the thumbs up reaction when you're ready to move on, and I'll introduce the next speaker, and AutoReel will play the next video. Any questions before we get started? Are you ready, judges? Want to practice that thumbs up reaction? One ready judge. Two. Do you find it, Dylan? I'm not seeing a thumbs up.
I found it. I think, let me try raising my hand. How about that?
Okay.
You see that?
No, you might just have to use your thumb.
Okay. Okay.
That'll work too. Thank you. Okay, so without further ado, let me go on to introduce our first presenter. We have Alireza Karduni, whose presentation will deal with how emotions in images affect our perception of news bias and credibility.
Sorry, everyone, one sec. I'm trying to find the video. All of them are in one tab, so I'm trying to figure out which one it was again. Sorry about that. Okay, can you see it now before I press play? Okay, good.
Hi, my name is Alireza Karduni, and I'm a PhD candidate in the College of Computing and Information Systems. Have you ever thought about how we come to decide whether a source of news is credible or not? There are many dimensions to this. For example, whether an account or the content in it is factual, or whether it is opinionated, might have a large effect on our opinions. But have you thought about how images affect our judgments? Since we're right around election time, let's say images about Joe Biden. Let's think of a scenario. You come about a source of news on Twitter and they are covering Biden a lot. However, the source might be using a lot of angry images of him. Would you find that source trustworthy? This is what my thesis is mostly about, how emotions in facial images impact users' judgment of bias in news content and source credibility. I ran a controlled experiment to investigate this question. I collected Twitter data from 8 different accounts. Some of the sources were right-wing and some were left-wing, and randomly assigned users to 3 groups: angry, happy, or mixed. For each condition group, I sorted the content of news shown to users based on the emotions in the images. So a user in the angry group would see content from each source with the angry imagery. Same goes for the happy condition. And the mixed condition, users would see content with a mix of happy and angry imagery. The hypothesis was that users in the angry conditions would rate sources as less credible in comparison to users in the mixed condition. I built a custom interface, which you see an image of here, that allowed users to go through tweets and rate using a new elicitation method that I developed. After collecting data from about 90 users, it turned out that indeed users assigned to the angry condition on average gave a lower credibility score to the sources. However, I did not find a difference between the happy condition and the mixed condition. So this might suggest that the angry emotion in images might significantly affect our judgment, and it is not the case for happy. This was an interesting finding. However, more interesting was that for right-leaning sources, the effect was smaller and sometimes reversed. What does that mean? Users in the angry condition on average found a couple of accounts as more credible as users in the mixed conditions, and that was surprising. Digging into it, it turned out that the content in the angry and happy conditions was really different and had a stronger effect on users' judgments than images. But that lesson learned overall in my study is that even though emotions and images definitely affect our judgments, the content is really important. And if we want to combat misinformation, not only we need to focus on content, we need to also pay close attention to images. And thank you so very much.
Judges, if you just want to let me know, I see Dylan, you're finished. Patrick, Laura, are you ready? Wonderful. Great. Our next presentation is from Arna Erega, and her title is Creating a Climate of Athletic Success, Assessing Collegiate Athletic Academic Centers.
Sport is a global language. Anyone, anywhere can connect over sport and athletics. In the US, sport carries a cultural significant meaning and has been identified as a microcosm of society where it is difficult to separate sports from wider societal interactions. The intercollegiate athletics is no different. The National Collegiate Athletics Association in the US oversees the intercollegiate athletics, and there are over 480,000 student athletes. The athletic programs are organized into teams, and they lose the individualized component, which is so prevalent in the US society. Also, this collectivistic approach is focused on doing what is best for the team versus what is best for the individual and their performance. Early research argues that student athletes exist kind of in a cocoon, which supports formation of subculture within the university campuses, which is different from the general student population. Development of athletic academic centers began in 1980s as a response to the outrage of low graduation rates and student athletes receiving lack of support. Since universities have invested a ton of money into development of such centers with a main goal of providing specialized services to student athletes. That has been criticized because the universities felt that they have been negatively impacted in the financial domain because the money has been taken away from other departments and has been contributed to serve only a small population of students on campus. In my study, I wanted to assess the culture within athletic academic centers and explore if student athletes really feel supported there. Such research has not been conducted yet. Therefore, there was no assessment readily available for me to use. So I created my own. I created 33 questions, separated them into 4 categories: athletics, academics, social connectedness, and mental health. And what I discovered was that overall, student athletes did feel supported there. However, the mental health area, they feel they receive least amount of support, and they stated that they wish they received more support, in particular when it comes to development of their mental skills. Furthermore, student athletes have very strict regimes, very busy schedules, many responsibilities, and they did report that oftentimes they feel overwhelmed by all of that, and that their stress in academics and social life affects their performance. Now, what do we do with all of this, and what can we do about it? Well, roughly 2% of student athlete population makes it to the professional world, leaving 98% of those who do not. Many universities have counseling and psychological services available on campus. However, current literature indicates that student athletes really do not utilize those services. Therefore, what we can do is work towards integrating mental health services within those athletic academic centers and providing student athletes with skills that can help them as they move forward. Furthermore, by doing that, integrating it there, we can contribute to destigmatizing student athletes seeking mental help. Thank you.
Okay, it looks like our judges are ready. Our next presenter is Nitika, who will be speaking about chemogenomic screening identifies the HSP70 co-chaperone DNA JA1 as a hub for anti-cancer drug resistance.
Hello everyone, my name is Nitika and the focus of my PhD thesis is to answer the question that can we make cancer cells more sensitive to existing drugs by removing HSP40? So most of us know that cancer is a deadly disease, but sadly there are very less therapeutics available for cancer, and whatever is available is toxic to the patients in clinic. So in our lab, we are focused on identifying strategies that make these anti-cancer drugs more potent. Now, most of us might not know that when a cell makes a protein, it's formed in a string. And this string needs to be wrapped like a ball to make this protein more functional. Here comes the role of HSP40. So HSP40 is just like a repairman of our cell, which fold these protein and make them active. So we had this idea that HSP40 somehow is also contributing to stabilize or fold these cancer protein, which in result make these cancer cells more resistant to anti-cancer drugs. So what we did was we used this anti-cancer drug library, which had 131 compounds, and screened it against cells which do not have HSP40. And these are prostate cancer cells. Fascinatingly, we found that 40 drugs work better after the loss of HSP40 gene. This was very exciting. So now we have, obviously we know that we cannot remove a gene out of a person in a clinic. So for a substitute of that is using an inhibitor, which is our HSP40 inhibitor, which specifically binds and inhibits this gene in a cell. So now we have found a strategy where you have an anti-cancer drug along with HSP40 inhibitor. When you combine them, the cancer cells die. But if you see here, when you have these drugs alone, the cancer cells are still living. So this was really exciting for us. So the next step we are doing right now is testing this anti-cancer drug plus HSP40 inhibitor combination in mice. And once we get data which is positive from mice, we are going to proceed to clinical trials. And this will lead way to cure prostate cancer. Thank you so much.
Okay. Next, we will move on to Remi Ketchum, whose presentation is entitled Some Like It Hot, Surviving in Extreme Environments.
All right, hi everyone. So climate change is the single biggest threat to the planet. This is especially true for ocean environments where temperatures are increasing, leading to mass mortality events and a huge loss in biodiversity as more and more species go extinct. My research lies in trying to understand and make predictions for how species will respond to climate change in the future. And I do this by studying contemporary extreme environments, which serve as a really informative model, because if we're able to understand how species today have adapted and managed to survive in extreme conditions, we can use that information to make more accurate predictions about how species in the future will respond to climate change. So the extreme environment that I study is the Persian-Arabian Gulf. It is home to the world's warmest seas, and yet somehow organisms have still managed to survive in this environment. One of these organisms is the sea urchin. You can see here on the left. It's called the rock burrowing urchin, and it exists in huge numbers in the Persian-Arabian Gulf. So I've collected hundreds and hundreds of these sea urchins with the aim to understand how they cope with extreme temperatures. And I do this in two main ways. The first way is that I look at their microbiome, which is the set of bacteria and viruses and archaea that live in and on every living thing. You might have heard about it in terms of human health and probiotics and gut health. Well, the reason that we study it in sea urchins is very similar to why we study it in humans, because the microbiome metabolizes vitamins and minerals that it then makes available to its host. So what does this have to do with climate change and extreme temperatures? Well, essentially what I do is I look through hundreds of sea urchin microbiomes and I try to identify bacterial species whose abundance in the sea urchin confers or gives the sea urchin an increase in thermal tolerance. The second way I do this is I look for signatures of evolutionary adaptation. So I sequence hundreds of sea urchin genomes and I look through these genomes to try to identify SNPs. A SNP you can see on the right here. It is a single nucleotide polymorphism, or it's essentially just a base pair mutation. And these mutations can lead to downstream effects where protein conformation and stability and function changes. And a change in protein stability and function can lead to an effect in whole organismal function. So I identify these important SNPs, and then I try to figure out what genes they're in. So let's say there's an informative SNP that's in a gene responsible for a heat shock protein. Well, that can tell me a little bit about how the species has managed to survive in extreme conditions by changing its heat shock protein. So in this way, I'm able to identify key bacteria and key genes that allow the sea urchin to survive in extreme conditions and hopefully provide insight into how species around the world will survive under climate change conditions. Thank you.
Great. Next, we have Amanda Sargent with her presentation, Men versus Women, Who Gets More Support for Work-Family Management?
Substantial numbers of American workers are now working from home due to the COVID-19 pandemic, making balancing work and family demands increasingly difficult. Historically, women have borne the brunt of caretaking responsibilities, but men also provide family caretaking, with recent research suggesting men are actually increasing their caretaking contributions during the pandemic. This means that both women and men need support from their organizations in order to effectively manage their work and family responsibilities while also maintaining their own well-being. But Do men and women actually get the same levels of work-family support? This is the question my research aimed to answer. Now, my thesis was conducted prior to the pandemic, but my findings remain relevant, or perhaps even more relevant now in the world of COVID-19. I argued three things. First, that because societal gender stereotypes associate women with caretaking and men with breadwinning, supervisors who believe strongly in these stereotypes would provide more support to women over men. Second, a person's occupation also ought to influence the levels of work-family support they get from their supervisors. Specifically, people working in male-dominated occupations like IT or finance, where masculine gender norms of behavior are particularly strong. These are things like expectations of working really long hours or prioritizing work over family. These people would receive the lowest levels of support. Finally, a person's gender, occupation, and the degree to which their supervisor holds strong stereotypical gender beliefs would combine, resulting in unequal experiences of work-family support for women versus men. Sadly, I was right. My findings suggested that people working in male-dominated occupations received lower levels of support than people working in female-dominated occupations. Furthermore, women received more support than men, regardless of occupation, or the gender stereotypical beliefs of their supervisors. This means that men received the lowest levels of support, especially if they worked in a male-dominated occupation and had a traditional supervisor, indicating a negative gender bias against supporting men's work-family management. So, what do we take away from this research? First, unconscious bias is alive and well in the American workplace and can result in unequal treatment of men versus women when it comes to supporting a healthy work-family balance. Second, my findings align with research suggesting implicit bias training is not enough to combat gender inequality in the workplace. Rather, organizations must take action and address the policies, processes, and practices that exacerbate gender inequality to ensure all employees are supported equally, regardless of gender. Thank you.
Okay, next we have Karthik, Srinivas, Madabushi, who will be presenting on CFD simulation of rotor system.
Good afternoon. How many people here are intrigued by drones, quadcopters, or other unmanned aerial vehicles? I am. I was so fascinated by them that I have bought one for myself on my birthday. So why do I like them? One, flying them is super exciting and fun, and the controller is very much similar to a PS5 or an Xbox controller. This interest in drones has led me to research into this topic, CFD simulation of quadcopter configurations. To give you all a brief idea about CFD, it means computational fluid dynamics. For example, when there is any wind blowing near a tree, it would cause leaves to move and rattle. Here, wind is exerting force and causing motion. The motion generated by any fluid here or anywhere else is governed by a set of mathematical equations which are quite complex and involves partial differential equations. So solving these equations using numerical models and physics models is what CFD is all about. I have developed CFD modeling schemes to simulate quadcopter motion. On the top left, you can see an image of a quadcopter with 4 rotating blades. The rotating blades are very crucial to CFD because these would rotate and push the air around it. This motion generates the forces which are required to propel the quadcopter upwards. I have developed CFD methodology to predict these forces and other necessary simulation parameters. In any research, it is my personal belief that validation is the first and crucial step. This is because it would help us test out various strategies and let us know if we are on the right track. I too have done this validation study, but instead of doing it on the entire quadcopter model, I have done it on a single rotating blade, as you can see on the top right image. This is because it would help me conserve a lot of computational resources and time during the testing phase. When I have developed a successful CFD methodology for a single rotating blade, I have applied and developed this scheme for the entire quadcopter model. On the bottom left, you can see a real-time image of a helicopter and some ring-like structures form beneath its blades. These structures are called vortex structures. On the bottom right, you can see an image from my CFD model which also shows similar vortex structures. This shows that my model is very well predicting and is comparable to the experimental results. The purpose of this model is it would help us identify the bottlenecks which are limiting the performance of the quadcopter. It would also help us to make design-related decisions faster and also eliminate the requirement of a physical prototype. Thank you.
Okay, next, and let me say that this order was randomly generated. You might notice it's not alphabetically, AutoReal randomly generated this order. Next, we have Pedro Regalado, who will be presenting on unifying mixed reality and IoT for immersive and connected health.
Imagine if I could tell you that you will have a heart attack before you even know you're having one. Around the world today, diagnosis and monitoring of health issues have attracted the interest of many researchers in the field of healthcare. With the advances of the Internet of Things, coined as IoT, healthcare services have become faster and more efficient. Researchers have proposed a number of solutions aiming at creating systems that help users manage their health. However, these existing solutions suffer from several limitations in terms of throughput, security, and large amounts of data. Despite it being a new technology, IoT is changing the way automation works in an interconnected world. However, these IoT systems are still unable to ensure efficient, engaging, and real-time proactive decisions in healthcare. What we propose is an advanced intelligent discovery system coined as AID system that uses a mixed reality technology combined with IoT to create an infrastructure that can help a user monitor their health in real time. Not only this, but the biggest thing about this is that you can create shared experiences. This is not you alone, but now you can involve a doctor, you can involve family members, and if something happens to you, then you can involve the police as well. In order to become some of these limitations that exist in diagnostic and monitoring systems, we are including the 5G emerging technologies based in the interaction between physical and virtual objects. You are getting a headset, as you can see here to my left, you're putting them on and you're able to analyze all of your data from glucose, your heart rate, as well as speed, pace that you're walking through, and be able to create that shared experience with your doctor and others as well. In this world where we're having meetings virtually through Zoom, WebEx, Facebook chat, and other social media, it's not enough to just see one another from the shoulder and up. We want to be able to create this immersive experiences where not only you're seeing me, but you're seeing my whole scene and environment around me. I want to feel like I am part of this family, part of the doctor, and I'm feeling it. And telehealth has been one of the biggest growing industries in the past decade. With the new technology that we're carrying, that we're holding, we are proposing to create this system in real time so that everyone can maintain their health and not have to wait till they get to a disease to go to the doctor and see what's going on. They say that the first step to solving a problem is realizing that there is one. In healthcare, the first step to not getting a disease is by maintaining your health and taking the proper medications and proper details to take care of that and not let it get there. Thank you for your time.
Okay, next up, we have Monica Rasmussen, the impact of climate on rock cracking.
Have you ever gotten a crack in your windshield? How did this happen? Usually you get some sort of initial flaw, like a rock hitting your windshield while you're driving on the highway, and then the crack slowly starts to grow away from that flaw. It starts very, very slowly and then gets faster over time, and all of a sudden you have this huge crack in your windshield. This process, where relatively small amounts of stress can get concentrated on that crack and cause it to grow over time, is called subcritical cracking. This process can happen in all sorts of materials, including rocks. So something as strong as a piece of granite, if you have an initial flaw, which all rocks naturally do, then relatively small amounts of stress can cause that flaw to turn into a crack that continues going through the rock. So just like your windshield, rocks can crack slowly until they break. What sort of stresses are being put on rocks? If they're just sitting out in the sun, that's actually enough stress over time of heating and cooling and expanding and contracting to cause a crack to form and propagate through and break the rock apart. We know this through fracture mechanics theory, and we've confirmed this through laboratory testing. We can take pieces of granite, put an initial flaw in the granite, put a little bit of stress on it, and then change the conditions. So we can have it be a bit wetter or drier or warmer or cooler and see how that cracking changes. Now, laboratory testing and theoretical mechanisms are incredibly useful, but we need to validate those with real-world measurements. For a geologist, this means going out into the field and looking at rocks. We can look at rocks that are anywhere from 100 years old to 5,000 years old to 100,000 years old and measure all of the cracks that we find on those rocks. By measuring all those cracks and then arranging that data in order of the age of the rock or the amount of time that it's been sitting on the surface, feeling the stress of the sun, we can arrange what we call a chronosequence, a time sequence of the cracking behavior. We did this for 3 different climates, and what we found is that in the wetter conditions, the rocks crack faster than in the drier conditions. Again, this is confirming what we know from laboratory testing and fracture mechanics theory with real-world data. Now, why does this matter to you? Subcritical cracking processes do happen slowly over time, but they're constantly happening in all of the rocks around us. So understanding how rocks are going to break off of a mountain or understanding how sediments are going to be formed is a controlled process that is mitigated by subcritical cracking. In addition, when a rock breaks open, that fresh face starts to interact with the atmosphere and it can pull CO2 out of the atmosphere, thus counteracting anthropogenic climate change.
Okay, our next presenter is Akintonde Abbas, whose presentation is entitled, "What if your HVAC unit could prevent a major power outage?"
What if I told you that your air conditioning unit could prevent a power outage and you could get paid for making that happen? Sounds too good to be true, right? Well, before I tell you about how that's going to happen, let's talk a little bit about the power grid. Electricity is generated by power generators in remote locations and are connected to the transmission network, which is operated by an entity known as the Independent System Operator, or ISO for short. Now, given the nature of the power grid, electricity consumption at every point in time must be equal to the electricity generated at the same time. And in fact, if this balance is violated, there is going to be a power outage. Now, this phenomenon is known as frequency regulation. So the ISO fulfills frequency regulation, and it does that in two major ways. The traditional approach is to control the power output of the generators, but this often results in inefficient operation of the generators, increased carbon emission levels, and also increased system operation costs. Now, the other approach, which is the novel method, is to control the loads. But for that to happen, those loads have to be inherently flexible. Now, wait for it. Your air conditioning unit falls perfectly in that category. And water heaters can also be considered as flexible loads. But from the slide, it is clear that the ISO does not have a direct access to those flexible loads. So it relies on the load-serving entity that has that direct access to those loads. Now, given that the load-serving entity has that access to the loads, it could do so much more with those loads in addition to fulfilling frequency regulation. And to make that happen, it needs a decision-making framework to decide when to control the loads, which loads to control at each particular point in time, how much it's going to make from doing those controls, and finally, how much it's going to pay to the owners of those loads for allowing those controls. Now, this decision-making framework is what we've developed using a combination of mathematical, economic, and electrical engineering principles. And in fact, one of the case studies that we ran using that framework showed that the load-serving entity could increase its annual profits by about 17%. And each flexible load can get an annual remuneration of close to $400. So if you own an air conditioning unit and a water heater, you could be getting paid almost $1,000 per annum. Now that's a good deal. Thank you.
I might have missed someone there. Judges, you're all set? Okay, great. Finally, we have Lena Etzel presenting her presentation entitled The Future, a Looming Threat We Can All Relate to.
Most of us worry from time to time, and 2020 definitely gave us all something to worry about. When we worry, we typically think about the worst possible outcomes. And when our thoughts take over, they can really get in the way of our lives. Don't get me wrong, worrying to a certain degree can be really helpful, but it gets tricky. When we're not sure what will happen, we might start to worry. Now, the good news is that the worst possible outcomes almost never occur. But the bad news is that worry creates the illusion that we think we can predict what will happen, so we keep on worrying. And we do that at the expense of our own health and our own well-being. Let me give you an example. This is Freddie, and Freddie is a medical student at UNC Chapel Hill. And Freddie's worried. He's worried about his finances and whether he'll be able to pay rent next month. He's worried about his relationship with his boyfriend, Sam. And he has a big exam coming up, and he's worried that he might fail. And on top of that, he's worried about COVID-19. So what could Freddie do to deal with his worries? Well, like we see in picture 1, he could think about his worries so much that he almost feels like he's drowning in them. And we call that self-immersion. Like we see in picture 2, he could give himself some space and think about his worries from a fly-on-the-wall perspective. We call that self-distancing. And then lastly, like in picture 3, Freddie could show himself some kindness. He can remember that he's not the only one who has these worries. We all worry. It's part of being human. And Freddie is doing his best. And graduate school can be really tough, especially in the midst of a pandemic. We call that self-compassion. In our study, we asked people to identify something that worries them, and then we had them write about their worry using one of these 3 perspectives for just 3 minutes: self-immersion, self-distancing, or self-compassion. Guess what we found? People who wrote about their worry from a self-compassion perspective felt less anxious and worried less. So we all worry from time to time. And while worrying can be really helpful, it can also really get in the way of our lives. In our study, we showed that we can change how we relate to our worries. For example, people who wrote about their worries from a self-compassion perspective seemed to fare best. So with a couple of weeks left in 2020, I want to leave you with a challenge. I want you to identify something that worries you and then show yourself some compassion. Thank you.
Okay, I am going to be a little bit old school here for a minute. Could I get you all to unmute and give these competitors actual applause for that tremendous effort?
Yay!
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 Good job.
Good job.
Good job. Good job, guys.
I know that's not the tech-savvy way to do it, but I want you to hear some applause and a little bit of praise, because these are tough times. A lot of grad students are having trouble being productive, more or less doing something extra that might be a challenge for you, putting yourselves out there and producing a video like this. So before we even go to scoring, I want to congratulate you on taking that step to learn and grow. I love it. Now, the judges, you should all have in your chat a link to a different Zoom conference. So I would like you to leave this WebEx and go to the Zoom conference. And if someone could privately chat me that as well, I will meet you there and we'll deliberate and tabulate. In the meantime, AutoReel will oversee the People's Choice Award voting. And as soon as we're tabulated, we'll meet back here to announce the winners.
All right, everyone. So let me go ahead and share the instructions for the People's Choice Award. I hope everybody's doing well, by the way. Happy Friday. Okay. Do you see it? Somebody give me a thumbs up so I know we can see it. Great. Okay, so this is what you're going to do. So this is the People's Choice Award. And remember that you get to vote for anyone you like. If you're a competitor, you are allowed to vote for yourself. This award is separate from the top 3 winners who are going to get cash prizes. You will get a certificate for the People's Choice Award and also, nevertheless, bragging rights. So for instance, the way you're going to vote is you see these numbers on the left column. That's what you're going to text to the number on top that's highlighted in yellow. So for instance, if I wanted Alireza Karduni if I was going to vote for him, I would text 1 to that number. Or if I wanted Lena, for instance, I would text 10 to that number. Does that make sense? Do you need me to explain anything else? And like I said, as a competitor, you are allowed to vote for yourself.
Adaril, did you see that there was a comment from someone that there are people in other countries and they're asking how they can vote? You're on mute right now.
Sorry about that. So that is something we actually did not think about. Wow, that's a very good point. Let's see, you know what? Why don't you privately, whoever you are, why don't you privately message me your vote? If you're comfortable doing that, if you're comfortable not being anonymous in that case, you can go ahead and do that and I'll add it up to the rest of the votes. Sorry about that. While we're waiting for the judges, feel free to continue voting for People's Choice Award. Obviously, if you've already texted your vote, please respectfully don't private message me your vote either. We don't want to cheat through the system. But in the meantime, feel free to grab food, take a break. I'm not sure how long they're going to take, but we told them for about 10 minutes is when they could talk amongst each other until they return.
Autoreel, do you have a People's Choice winner to chat for me?
Yes,
To
let me
chat
go
to
ahead and
me?
pause. Yes, let me go ahead and pause the stop the screen share and go ahead and do that. 1 sec.
Okay. Well, I have to say a few things to delay and keep everyone in a lot of suspense right now. So I can't just, you know, blurt the big news out. But I do want to highlight that this competition is important for a number of reasons. It's important because it highlights UNC Charlotte as the urban research university that we are. I'm just amazed by all the different research that you all are doing, in addition to what the people in the preliminary rounds were doing. There's such a range. It's so far reaching and so important. So I really appreciate that. And I appreciate the important work being done by our graduate students here. Also, of course, I'm a fan of the skill that this builds. Being able to explain your technical, highly specialized research in a way that anyone can understand, it's always been important. We've always known it was important. But I think all the challenges that we have faced recently and over the last couple decades have really highlighted that if we're ever going to be able to build solutions to society's most vexing problems, we're going to need teams of people. We're going to need our scientists to work with our business people, to work with our politicians. So there's probably never been a more important time to build this skill. So again, congratulations to all the participants. And I'm about to announce the winners. I will start with the People's Choice Award, which goes to Remi Ketchum. Congratulations, Remi.
Thank you.
Great job. Then I will start with third place. which comes with a $200 cash prize and goes to Lena Etzel. Nice
Thank
job.
you.
Second place, which comes with a $300 prize, goes to Amanda Sargent.
Thank you.
And first place, which comes with a $500 cash prize and the ability to move forward in the 3MT competition, goes to Akintonde Abbas. You are the winner of the 2020 3-minute thesis competition.
Okay. Thank you. Thank you, everyone.
Well, this pretty much wraps it up. I'm so glad that all of you were able to join today. I appreciate the time you put in to watch all this great presenting and learn about all our wonderful research. I wish you all a wonderful weekend. Thanks, everyone.